Great. So welcome everyone to this webinar, the series 1. You're going to be having upcoming series, so you should stay tuned for that. So we're going to be talking about network security essentials. And let's introduce our speakers. So my name is Nelson Bassi, and I am the CTO at Flowsoft.io. So a little bit of context. Flowsoft is an AI-powered OSS and BSS for ISPs. We help ISPs with anomaly detection, managed reduce, provisioning, billing. We have also managed TR069 GIS. And we also have AI voice agents for customer support, live troubleshooting for ISPs. And I am an engineer, ex-engineer at Google London before starting Flowsoft, and also an ex-engineer in Kigali, Rwanda. So I have a lot of experience with building scalable systems and securing large-scale networks for government services and also for companies like Google and also for Flowsoft. Then my colleague, Matheus Ferrari. Matheus is a network security specialist and a consultant from Brazil. He is known to consult for over 200 ISPs across Brazil and has a strong and in-depth experience in network security and also a CCNA certification. So now that we've known our speakers, let's get straight to it. So yeah, starting from the question, what exactly is network security, right? So we are really going to break it down into three main definitions. One is confidentiality, right? How can we ensure that only authorized users can access sensitive data is the very first thing about network security. And then there is, the next thing is integrity, right? That data that we've made confidential, how can we ensure that it has not been tampered with, whether in transmission or in storage? And leading to that is the third thing, which is availability, right? Not just it being confidential and it not being tampered with. Is it highly available, right? Can our legitimate users always have access to that data whenever they want? All of that is part of network security. And that's going to be the basis of this talk. Then we can ask, why is it critical or important for ISPs? I think one thing we can all agree is that ISPs are more or less the backbone of the internet, right? And they are also very high value targets for cyber attackers. And it's also very critical because just one compromise for an ISP can lead to, of course, widespread disruption of services, data breaches, and also very important, a significant loss of customer trust, right? Which ISPs cannot afford to lose that. And having a strong and secure network gives ISPs a strategic and competitive edge in the industry. Then let's take a look at what the security landscape is, what is happening in the world, right? So we can have an idea of how, like the scale of what this is, right? These are snippets of news agencies reporting about cyber attacks globally. And these are very recent reports, 2025 and 2024, right? I'm not sure if you know about GOX. It's one of the major ISPs in the US. And recently, last year, June, I think just barely a year from now, they had millions of their Wi-Fi routers hacked, right? Their residential gateways were hacked and used as, of course, botnets, right, for subsequent attacks. So imagine the kind of scale that is and how detrimental that is to an ISP. And on below here is the National Security Institute, which also lists several threats that happened in the ISP space, also impacting millions, right? And not even all. We have a report from Radware. I'm pretty sure most of us know Radway, which is one of the providers in the security space. So they had a report just in 2025, right? And it happens that 43% of global network attack were targeted towards telecommunications. And that is a huge number, if you ask me. Almost half of the attacks. Some goes to, a part of them went to the government, a part went to healthcare, but telecommunications faced a lot of those attacks. And some of the attacks that were prominent were UDP and DNS amplification attacks, which we are going to talk about in this webinar. So this gives us an idea of how important this is. Some ISPs might say, okay, I have not experienced this in my network yet, but are you prepared? Are you ready to basically be able to mitigate this if it happens to you? So that is why we have this talk, to bring not just awareness, but bring practical steps on how to mitigate and understand what these attacks are. Moving on, let's look at the common landscape of these threats. Right, the three top ones, and we are ranking them in terms of severity, right? We have the DDoS attacks, which we are also going to explain in details as we go into this talk. We have how, like, BGP hijacking, where you can maliciously hijack BGP routes and intercept traffic. Malware propagation, where, of course, the attackers can exploit residential gateways and turn those into botnets, thousands into millions of it. We're also going to talk about insider threats, and it's actually very important because most ISPs focus mostly on the outside perimeter, but forget that insider threats are also very, very important. Also, supply chain risks, right? The hardware that you're purchasing, right? How secure is it? The firmwares, are you up to date with it when you're deploying it to your customers? And that leads us to the edge device exploit, right? What measures are you putting in place so that your CPEs, your ONTs, your residential routers or gateways are up to date, and everything is basically secure and firm and hardened? So we're going to then talk about the first attack that we had on our list, which is the DOS, denial of service attack. So by definition is an attack where an attacker is designed to overwhelm a system, right? And then they do this by flooding the target or the victim, then avoiding actual legitimate users to access the system. They really have to, when you have these kinds of attacks, there are actually two major end goals: either to exhaust your system resources, or to actually just block your actual legitimate traffic, which are also going to basically talk about both of those cases. Like I mentioned before, how does this work? The attacker just ends up sending massive volumes of requests to a target system, right? Remember the botnet that we talked about? So an attacker can basically set up like an agent of thousands of different residential gateways, and they target a victim. And then the network struggles to process that flow of requests. And then the result is that the actual legitimate users cannot access the service. They have basically either low performance or degradation. And now, moving from there is the distributed denial of service attack, DDoS. And this attack is an even more powerful version of DOS. So this is where, instead of the attack coming from one source, it's coming from several botnets, and most likely the IPs are spoofed. And then it is very difficult for your edge routers to detect the source of these attacks, and also very difficult to mitigate. But we are also going to explore practical ways to reduce the effect of these attacks if you cannot completely mitigate it, or how you can actually also prevent it. how botnets work in the attack. So the hacktivist or the command of the botnets, they can basically set up a control of these botnets, then attack. Then the next thing is they send attack execution. Now, like I said before, this bot sends massive amounts of requests to the target user, disrupting the service. And if your service, basically, it can basically flood your whole bandwidth and not allowing access to come in. Still on the DDoS attack, we are also going to break it down into different categories, right? One is going to be the volumetric attacks. Then we're going to also talk about the protocol attacks. So volumetric attacks is, like I said before, for DDoS attacks, the aim are either two things. The attacker is trying to achieve two things. They're either trying to make sure that your system resources, your CPUs or your memory are overused, right? So that you cannot serve your actual valid or legitimate traffic. Or the goal is to just shut you off completely. And that happens when they push so much into your link that you cannot even carry. Meaning that your edge routers won't even get the chance to even enforce the ingress firewall filters. So, and these volumetric attacks actually are the most hardest ones to mitigate. And we're going to talk about examples of them like DNS amplification and UDP floods. Now, on the other hand is the protocol attacks, which the attacker basically tries to exploit how protocols were designed. For example, the TCP three-way handshake, right? They exploit that to also flood your network, which we are going to go into details of that in the next slide. The next category is infrastructure specific. So this is a bit more high level, where the attackers target specific protocols like TR069 or your Reduce servers, right? To also flood those part of your network. Now we have the application layer where they can also send HTTP DDoS to you, right? So I think we are basically going to focus on the top two, the volumetric attacks and the protocol attacks. And for us to even do that, we need to go back to the fundamentals and remind ourselves or revisit what TCP/IP are. Now, TCP/IP is the layer 4 of the transport, is the layer 4 TCP model called the transport layer, right? Which plays a crucial role in data transfer reliably between devices. Think of it like a post office, right? Ensure that data is being sent from one point to the other. And the key responsibilities, which I'm just going to list out here, it ensures end-to-end communication, right? Make sure that a direct link is being opened between the client and the server, and then reliable data is being transferred. It also enhances flow control. So flow control, you think of it like the server and the client basically have different capacity. For example, the server can also, let's say, have a window size of packet that it can basically accommodate, but the client is sending a lot more window packet size. So with TCP, both can agree on a window size. The server can tell it, oh, this is how much I can carry. Then subsequent packets are then going to be throttled to that window size, to that packet size. Also, multiplexing allows, so basically TCP can allow multiplexing. You can stream videos while you're also browsing the web, right? So then it leads us to how does it actually work? Now we go into the nitty-gritty of the three-way handshake. This is how a TCP connection is opened between a client and a server. So just like the name, three-way handshake, it's like a series of events. The first event is when the client that wants to open the TCP connection sends a SYN packet to the server saying, hey, I want to open a connection with you, and this is my sequence number. And if the port is open, the server can receive TCP connection. It receives the connection, and then it sends a sync ACK packet to the client, telling the client, I have seen a request. Yes, I can connect with you, and we can open a link. Now, the last way, the client also has to acknowledge the sync ACK by saying, okay, I acknowledge your acknowledgements, and then a link is actually opened. And then the TCP have different states, which we have the half open and the full open state. So now this is the protocol that attackers exploit in what we call the SYN plot, which I'm going to also look into in details in the next slide. So meaning that if the server receives a SYN request, the server has to wait. If the server receives a SYN, right, and sends a SYN ACK, the server has to wait for the client to send the ACK for a connection to be opened. But if it doesn't receive the last acknowledgement from the client, that connection stays open, right? And the server can retry. So that is where the attackers exploit this protocol with the DDoS SYN flood attack, which is the next thing that we are talking about. So a SYN flood attack is a type of denial of service attack that exploits a three-way handshake like we talked about. So the goal is to overwhelm your system, making it highly impossible for legitimate traffic to pass through. And how does it work? So like we explained in the previous slide, the attacker gathers agents or legions of botnets, right, that has been, of course, infiltrated by malware. And then they send the sync packets to your server without all of them sending the acknowledgement packet back. So your server receives a lot of this requests for connection, and then opens them, waits for acknowledgement, and nothing happens. And those are kept in memory. It also consumes CPU because the server has to basically open a block, right, and to store all of those all of those requests in memory. So the server responds. The server would respond its own sync ACK, right? Then expecting the final message from the client, which is the final ACK, but the client is not sending it, right? Then the attacker never sends the final sync ACK, leaving the connections half open. So with these, if not properly mitigated, which we're going to talk about how you can actually mitigate this, then your system is in a half open state with millions of open TCP connections, and thereby blocking or limiting legitimate traffic to go through. Then the next thing we're going to actually say, if not properly mitigated, this is the state that the SYN flood attack will leave your server, right? And the worst thing is, this is the state that it will leave the ISP itself. It will also give you an attack. And luckily, we are here to prevent such things from happening. The next kind of attack we want to talk about on our list is the DNS amplification attack. So what is this? So we all know about the DNS. What the DNS is, domain name server, which is a server that helps us to resolve domain names to IP addresses. Again, attackers also exploit this, right? So it's a type of attack where it is UDP based, and it's also stateless because it is UDP. And they send large amounts of DNS response traffic to a spoofed target. So note two things: response traffic and also to a spoofed target. So those are very critical to understand how this attack works, because you need to know how they work before you can even mitigate or stop it. Now, this is an example of how it works. So the attacker has a legion of botnets, and what they do is they send DNS requests to a DNS server, any open DNS server that is also susceptible to this challenge. They then spoof the IP address of those botnets and change the destination IP to the victim's IP. So meaning they will change destination IP to your IP, right? Meaning that they trigger the DNS resolution. So imagine 1 million, okay, let's even say 700,000 botnets sending a DNS resolution packet to a DNS server saying, hey, I want to know what the IP address of these lots of domain names are, and then they send that to a valid DNS server, but then they change the destination IP address to the victim's IP address, basically to an ISP's IP address. Now, what happens is that the response of all of those millions of DNS requests are then sent to your own server, which you never made those requests. Now, this is very difficult to block because one, these requests are legitimate, like they are actually from legitimate DNS resolvers. And also they are from different servers. And it's also a spoofed IP. So you really cannot have a static IP filtering. And the other thing here that I want to take note is the amplification. Like, what exactly is that? Like a DNS request is basically like, say, maybe 60 bytes of data sent from the DNS resolver to the DNS server, right? But then what the attacker does is that instead of sending a request for one domain name, they are going to request all domain name, like all, let's say, the subdomains of a particular domain name, and basically hundreds of them. And that basically amplifies the response. So one request can be amplified, let's say 100x. So they send 60 bytes of packets, and then let's say 1,000 bytes is being sent back to the victim server for each of the response. Then just multiply that by times 1 million, right? Then you can imagine how much traffic comes into the victim server. And this is how attackers end up also basically consuming the link of a particular ISP or a particular network. So how it works, I think we already explained this. Then the attacker sends a forged DNS request to a DNS server, which is usually like a public open resolver with the source IP of the victim. The next thing is the amplification, like I was explaining before. Now, the attackers will intentionally say, oh, instead of saying I want to resolve a particular DNS, they're going to use the any keyword saying I want all the records of a particular domain. That is part of the amplification of the attack. Now, to even make it worse, if the DNS server has the DNSSEC enabled in it, then this can even get worse. Because this, when this is enabled, it adds cryptographic signature to the responses, which massively increases the payload size. Right? For example, a DNSSEC with an any query can result in a response of 4,000 bytes from a 60 byte request that was sent, which is almost a 70% amplification. So this is just from one botnet, and imagine this, let's say, sent to you 1,000 times per second, and also from hundreds of thousands of botnets. Now the implication of this is critical. Now, something also very interesting is that it's the irony of network security. The attacks are not that hard to initiate, but then the mitigation is what the problem is. So this is an example of a lab that we set up, that we sent an ICP spoof attack to a server, right? And one tool you can use here is the Scapy, the Python library that you can use to basically simulate a spoof attack. So this is also what we recommend that you use it to test your network, right, in a controlled state to see if your mitigation against these attacks go through. So using Scapy here, we basically simulated an attack to a destination address using random IP. So if you see in this command here, they text the IP, which the source IP there is a random IP. So this would generate random IPs for every 100,000 requests that we send. And we provide a destination IP. In this case, the destination IP is going to be the victim's IP. In this case, the ISP's IP. It could be even like the whole prefix, right? And then we send a raw ICMP packet, and then we are sending 100,000 of it on just one process. So let's say a good enough VM can handle lots of processes, and you can end up receiving like millions of requests from just one instance. Then this is amplified by the botnet, and also again amplified by the DNS responses in the case of DNS DDoS attacks. Now this is just a TCP dump that we basically traced on the request that we sent there, right? So basically, you can also simulate this to see how your network basically handles this kind of attempts or threats. One thing we also want to point out is the large-scale volumetric DDoS attack. So I think this is worth mentioning because there are some DDoS attack that you can mitigate on your end, maybe on your edge router, because you have maybe ingress and egress firewall set up properly. But there are also some attacks that you cannot mitigate on your local network. Just like we talked about, if their aim is to flood your link, right? So imagine an ISP with 10 GB bandwidth, and then they experience a DDoS attack that is swarming their link with 30 GB. The link is already saturated. So even whatever filters you have in your edge routers doesn't matter. So this is a case where you have to have planned for this ahead of time, which we are also going to talk about how to plan for such attacks, right? Because if this happens to your network, you are completely down until maybe you can find a way to externally reach out to your upstream. Hopefully they have an anti-DDoS service. If not, you would need to have a scrubber center, which we're also going to talk about as we go. So this is a kind of attack where the end goal is not to just block your resources. The end goal is to completely shut you down. And moving on today is we are going to then say, okay, with all of these attacks that we have mentioned and planned, how can we mitigate them? Right, and we are going to start with the very first stage, which is your edge router. Right, how do you actually make sure that your edge router is in a good place that it can be the first point of action for these kind of attacks? And the first point is you need to in part of your planning, you need to basically block known bad IP addresses, right? There are sites and platforms that have listed basically very top known bad IP addresses that you have to, and there are prefixes that you can actually block on your edge router. Second is the rate limiting and traffic pooling, right? You need to be able to, like, for all of these identified protocols, UDP, NTP, which is for network time protocol, how you need to basically have a good rate limiting for all of this in your edge routers. The next thing is going to be the ingress filtering, right? One mistake we see most ISPs do is they focus on blocking external IPs, or do not block private IPs that are coming into their routers. So a good practice is to also make sure that you block traffic coming from internal private or reserved IPs from the WAN facing interface, right? The 10.0.0, the 172, all of those, you should also make sure that they're also blocked from your edge routers. And then also disable unused services. Services like Telnet, which is preferable to use SSH, not with password, but with secret keys. NTPs, if you're not using a public NTP server, you disable those. all on your external interfaces. Now remember that we said this is assuming that the DDoS attack that you're having is not already overwhelming your link, right? So you can actually mitigate them on your router. And these are the steps that you can take. But then what are the actual plans that we can actually mitigate this, right? Now, you would need to properly have like a DDMS, a DDoS mitigation and detection system. An example of this could be OneGuard, which is a commercial license, or FastNetMon, which is open source, right? And the good thing with open source project is that you can also like run it on your own VMs. So this DDMS is the best way to mitigate against DDoS attacks, because they're going to provide you with live traffic monitoring, right? Which you are also going to set that up, which I'm also going to show in the subsequent slides. So this, for example, FastNetMon is going to have a setup to monitor your live traffic and analyze the network to detect unusual patterns. It then identify and mitigate threats like the SYN flood that we talked about, the UDP floods, and the NTP amplification attacks. So how this works? So there is what we call the anomaly detection protocol, which is mostly like a machine learning model. So what it does is it's a model that has been trained on patterns, right? And because it's a learning model, the patterns are not static. It's not like an alert and you say, oh, if the threshold is over 10 GB, trigger an alert. It's not that simple. So the machine learning models are able to figure out thousands of parameters about a particular data. And with that, they can build their weights and biases and are able to know and detect when a slight changes occurs in the usual pattern of a traffic. So that is what powers most of these DDMSs, right? So with these detection, anomaly detection models in them, they can effectively identify whenever a threat begins instantly. I think with FastNetMon, which is used by AWS and also Google Cloud. So with FastNetMon, it can give you as quickly as less than 2 seconds notifications when there's an attack attempt, which is pretty quickly. Now, after detecting those SYN flood attacks or the UDP flood attacks, it then goes on to block the malicious packets while letting the legitimate traffic go through. And it does that through what we call the RTBH, the remote triggered black hole. So how this works is the DDMSs, you're going to have to peer, right? Your BGP peering from your edge router to the DDMS, right? And then it can remotely trigger a black hole. So what is a black hole? So a black hole is basically a BGP route that you configure a BGP route that you can configure to say, okay, for a particular static route, just send it to node 0. So node 0 is basically just drop it, right? So then, because the DDMS is monitoring your traffic live, and then whenever it detects the slightest attempt of a DDoS attack, it is going to remotely trigger, right, and send a BGP session, a BGP packet to your router, right, for it to basically block that particular traffic. And they do that with the community tags, which we're also going to see how you can set up Fastnet, let's say with a MikroTik, right, and configure that to work. So also you also need to use a cloud-based scrubbing to filter out malicious traffic. So what is that? So let's imagine a scenario where an ISP has 10 GB of bandwidth and they are currently experiencing a DDoS attack of 30 GB, right? and of their link is automatically